Hello guys, welcome back to my YouTube channel. And for today's video, I'm going to talk about the overview or the chapter 5 summary in the NetAcad. So previously I made a summary video about the chapter 5 in the NetAcad. So for today's video, I'm just going to discuss the important terms or in the brief summary of the chapter 5 in the NetAcad. So without further ado, let's get started. So the first thing that the chapter 5 is the Ethernet protocols. We're going to discuss the Ethernet frame. So in the Ethernet encapsulation, the Ethernet operates in the data link layer and the physical layer. And also the Ethernet supports the data bandwidths from up to 10 Mbps through the 100 Gbps, and the Ethernet standards defines both the layer 2 protocols and the layer 1 technologies. So MAC sublayers, we also have here in the MAC sublayers, which is the MAC constitutes the lower sublayers of the data link layer. So it is also responsible for the data encapsulation and media access control. So it's the Ethernet evolution. So in the Ethernet has been evolving since its creation since in 1973, and the Ethernet frame structure adds headers and trailers around the layer 3 and the 3 PDU to encapsulate the message being sent. And of course, the Ethernet frame fields, which is the minimum Ethernet frame size is 64 bytes, and the maximum is 1518 bytes, which is 1518 bytes. And frame smaller than minimum or greater than maximum are dropped, and the drop frames are likely to be of the, the result of the collisions or other unwanted signals, and therefore considered invalid. Next is the Ethernet uh, Ethernet MAC address. So in the Ethernet MAC address and the hexadecimal. So MAC address is a 48-bit long expressed as a 12 hexadecimal digits. So MAC addresses Ethernet identity. So the IEEE requires a vendor to follow up into two simple rules rather. The first rule must be the vendor must use the vendor's assigned OUI as the first 3 bytes, and the second is the all MAC addresses with the same OUI must be assigned as unique unique value in the last 3 bytes. And we also have here the frame processing, which is the frame processing. The NIC compares the destination of MAC address in the frame with the device physical MAC address is stored in the run, and if there is a match, the frame is passed up to the OSI layers. So if there is no match, the device discard the frame. And when it comes to MAC address representations, we have here the MAC address can be represented with colons, dashes, or dot, and it is also case sensitive. So we have also here the unicast MAC address. So in the unicast address, a unique address used when a frame is, for example, sent from a single transmitting device to a single destination device. So the source MAC address is must always be a unicast. So remember that uh, next is the broadcast MAC address. So the broadcast MAC address is used to address all of the nodes in the segment. So the destination MAC address is address of the hexadecimal, which is the 48 ones in binary. Next is we also have here the multicast MAC address. It is used to address a group of nodes in the segment. So the multicast MAC address is a special value that begin with the hexadecimal, which is the 01-00-5E. So the remaining portion of the multicast MAC address is created by converting the lower 23 bits of IP multicast address into 6 hexadecimal characters. So the MAC address table, which is the switch fundamentals, an Ethernet switch is a layer 2 device. It is used as a MAC address to make forward decisions. The MAC address table is sometimes referred to the content address table or the CAM table. So learning MAC addresses switches dynamically build the CAM or the content address table by monitoring the source MAC. So every frame that enters a switch is checked for a new addresses. So the frame is forwarded based on the CAM or the content address table memory. So in filtering frames, since the switch knows how and where to find a specific MAC address, so it can filter the frames to the port only, and the filtering is not done in the destination MAC. Destination MAC is not present in the CAM or in the content address table memory. So next is the switch forwarding methods. So in the switch forwarding methods, we have here the frame forwarding methods on the Cisco switches. There's the store and forward and the cut through. And we also have here in the cut through switching, the fast forward switching, the lowest level of latency, immediately forwards a packet after reading the destination address. It typically cut through method of switching, fragment fragment free switching, switch stores the first 64 bytes of frame before forwarding, and most network errors and collisions occur during the first 64 bytes. In the memory buffering of on switches, port-based memory and shared memory. So we also have here the switch port settings. So in the switch port settings, duplex and the speed settings. So the full duplex is both ends of the connection can send and receive simultaneously. So and a half duplex, only one end of the connection can send at a time. So a common cause of performance issue on internet links is one port on the link operates a half duplex and the other on the full duplex. So auto MDX, it detects the types of connections required and then configures the interface accordingly. So it helps reducing the configuration errors. And also we have here the MAC and the IP. So the combination of the MAC and the IP facilitates the end-to-end communications. For example, the layer 2 addresses are used to move the frame within the local network. So in the layer 3 addresses is used to move the packet through the remote networks and the destination on the same network. So in the destination on the same network, we have the physical address and the uh, or the MAC address is used for the Ethernet to Ethernet communication on the same network. And the destination on remote network is a logical address, which the IP address is used to send the packet from the original source to the final destination. And lastly, we're going to talk about the ARP. So ARP is the one that allows the source to request the MAC address of the destination. The request is based upon the layer 3 address of the destination known by the source. And ARP functions is the resolving IPv4 addresses to MAC addresses and maintaining a table of mappings. ARP uses the ARP request and the ARP reply to perform its functions, and the removing of the entries from ARP tables. And here's the entries are being removed from device ARP table, which is kaki a timer expires. So kaki timer are OS dependent, and the ARP entries can be simultaneously or manually removed via commands. So in the ARP tables on the iOS, so show IP ARP. So in Windows PC, it's the ARP-A. So also the ARP issues is the ARP broadcast. So the ARP request can flood to the local segment, and the ARP spoofing. So the ARP spoofing is when the attackers can respond to requests and pretend to be a provider of services. For example, is the default gateway. So that's it for today's video. So that's it for the chapter 5 overview or summary. If you like this video and if you learned something, please leave a like and share, and thank you for watching. Bye bye.